Hello, this is Professor Gavoor again, and we're talking about right now quality management part two, and we pick up where we left off, and we want to talk about two topics here to finish out the agenda for this presentation: quality gurus and process improvement and problem solving. So, what is a quality guru? Well, American textbooks on operations management and quality favor the following. They talk about W. Edwards Deming, they talk about Joseph Juran, they talk about Phil Crosby. Oddly, they don't talk so much about Armin Feigenbaum, who actually coined the term in the 50s of total quality management. But most of the time they ignore the Japanese. They might mention Taguchi, but Kaoru Ishikawa they don't talk about, and they may or may not talk about Taguchi. Noriaki Kano they don't talk about, and Yoji Akao, who was kind of developed something called quality function deployment, they don't talk about. I want to focus on three of them here. I'll provide a little bit of introduction to Deming, Juran, and Ishikawa. I've met all these guys. I've not met Feigenbaum, but I've met Crosby, Juran, Deming, Ishikawa, Taguchi, and Akao. I never met Kano. He was the one guy I would have loved to spend some time with. So this fellow, W. Edwards Deming, he was born in 1900 in Iowa, and he passed away in 1993 at the age of 93. He was a statistician and management consultant. He was got a PhD from Yale and his undergraduate degree from Wyoming, and then he got a master's from Colorado. And one of his big influences in the study of quality management was Walter Shewhart, who actually came up with the concept of control charts. So his degree from Yale was in mathematical physics. At Bell Labs, he worked with Walter Shewhart himself. He worked for the U.S. Department of Agriculture and the Census Bureau and was consultant to the Secretary of War. And after World War II, which 1945, when he was 45 years old, he went to Japan. And MacArthur brought him to work on housing and nutrition and agricultural production. But there was a small group of professionals, scientists and engineers in the Japanese Union of Scientists and Engineers, which people call JUSE or JUICE, to teach a quality course. And he taught that course. And it was a turning point in Japanese manufacturing. They took it to heart, and that course that he taught pivoted into the Japanese economic juggernaut of the 60s, 70s, and 80s, and in which they caught the Americans flat-footed, and we had to play catch-up with them. And I think right now you could probably say our things that we produce here are probably of the same quality as Japanese electronics and automobiles. Of course, mostly automobiles are produced here, they're produced there. Electronics have, for the large part, moved to China. In 1915, in July 1950, he sketched this out in one of his lectures. Not necessarily the Japanese, but he said if you improve quality, you decrease costs because of less rework, fewer mistakes, fewer delays, fewer snags, better use of machine times, and materials. This has nothing to do with consumers yet. It's just reducing your own costs. If you do things right, you don't have to do things over, and you save money. Productivity improves. You capture the market with better quality, and you can charge a lower price. You stay in business and provide more jobs and more jobs. Well, the difference between 1950 and now is that you stay in business, But usually automation has become such a thing with us that you don't provide more jobs. You probably do all of this with less jobs. He also sketched this out. Here's the job, and he's starting to look at things as a process. You have supplies of raw materials. You get the receipt and test of those materials, make sure they're usable, and then you start adding value to them in production, assembly, and inspection. And we do a lot less inspection than we did in 1950. We used to inspect in quality to some degree. Almost now, inspection is not used to the same degree. Then you distribute it to consumers. You do consumer research to find out what consumers like and want, and make more of that, and innovate to satisfy your consumers. And you keep this going, and it keeps this going. In Japan, they tried to pay him for that first training session. And he knew that they had no money, and he was already there in the U.S., so he said, I'm not going to take any pay. So the Japanese Union of Scientists and Engineers decided to name an annual quality award after him. And they used that quality award, which had some very tough standards and was tough to get, so it became very prestigious to the Japanese. And the Deming Prize for application is awarded to a company for improved use of statistical theory in organization, consumer research, design of product, and production. They give this award, and they used it to improve. Toyota used it incredibly. They wanted each one of their divisions to get it. They wanted each one of their suppliers to get it. And as they did, they leapfrogged basically U.S. automotive manufacturers and produced a car that was more reliable, not necessarily more durable, more reliable, didn't break down nearly as much, had more interior room and trunk space, and cost less. Quality, cost, delivery. Better quality, lower cost, and they were able to design new cars faster than the U.S. So they're in this case delivery, not delivery of the product, but delivery of new designs was happening faster. They were eating the U.S. auto industry's lunch. There's a reason General Motors went from the late 1950s of 80% market share in the U.S. market to what do they currently have now, about 18, 19%? So his contributions are 2 books, Out of the Crisis and New Economics for Industry, Government, and Education. He's known for his famous 14 points. The System of Profound Knowledge, which is outlined in the New Economics. He did these 4-day seminars, which from 1985 to 1993 when we passed, 1,000 people would show up for each one of these. And he'd do 7, 8 of them a year at that age. And he was a cantankerous fellow that would, was kind of abrupt. He had a style about him that endeared himself to people, though. And people would attend these seminars. And he did the red bead and the funnel experiment. And he taught people what variation and how to manage variation, how to control variation, and the value of control charts and plan, do, check, act, which we're going to talk about in a little bit. In the 60s and 70s, he taught and consulted around the world, London School of Economics. He was in countries all over Latin America and the Far East and Europe. He made another trip to Japan. He was relatively unknown in the U.S. He retired in 75. He was 75 years old. And he was an emeritus professor at NYU and taught 1 class. Of course, NYU is all adjuncts. You got to know that. So he flew every Monday from Washington, D.C., taught a class in New York, and then took the shuttle back later that evening. all changed on June 24th, 1980, day before my birthday. NBC aired a documentary of Japan Can, Why Can't We? And it changed the course of quality management in the United States. The next day, it was all the buzz at Ford, where I was working at the time, in GM. And Ford actually said, we want to have this guy come in and give lectures. And some of his first lectures he gave, I got to sit in on them because I was a young kid then. And the older people in my warranty analysis department said, I don't know, who wants to go hear this Deming guy? I don't know, send the kid. So they sent me because they had to send somebody. And it changed my life. So the U.S. auto and consumer electronic industries were being hammered by the Japanese, Toyota and Honda, Sony and Panasonic. Sony was the Apple of the 1960s, 70s, and 80s. And they had higher quality and lower prices. So this documentary was really something. You can find it on YouTube and watch it if you'd like. As we got to learn more about what they were doing in Japan, we found out that this fellow, Kaoru Ishikawa, was a very important guy. He said through total quality control, with the participation of all employees, including the president, any company can create better products or service at a lower cost, increase sales, improve profit, and move the company into a better organization. Well, what the heck is he saying? He's saying this. It's almost the same thing as Deming was saying. He was born in 1915. He died in 1989. Deming, I had a chance to go to one of his 4-day seminars. I heard him at Ford. But I had the opportunity at the last 4-day seminar I went to in Minneapolis. I was waiting at the then Northwest Airlines lounge. And when I walked in, the executive lounge or whatever they called it, and Deming was sitting there. I said, Dr. Deming, can I sit with you, please? And we talked for 45 minutes. It was like amazing. Kaoru Ishikawa, I met once. I was at the national convention of the American Society for Quality. Back then it was called American Society for Quality Control, ASQC. Now it's just ASQ. And it was basically a year before he died. He died at the age of 73 in 1989. And it was in Anaheim, California, near Disneyland. I was walking down the street. On the other side of the street, I see this Japanese fellow walking, and I'm like, as he gets closer, I'm like, oh my God, that's Ishikawa. So I went over there and bowed and shook his hand and told him I'd read his books, and he said thank you, and he departed. So I didn't really get to spend much time with him, but it was an honor actually to meet him. So his fields were quality and total quality. He went to University of Tokyo, Institute of Technology. He's well known for innovating quality circles, the Ishikawa diagram. He got the Walter A. Shewhart Medal from ASQ, American Society for Quality, and Order of Sacred Treasures from Japan. We're going to talk a little bit more about the book that he wrote later. The other fellow that I like is Joe Juran. He outlived them all. He lived to 103, died in 2008. I heard the last speech he gave at the ASQC convention, the same one where I actually met Ishikawa. And he was theoretically retiring then, and he just basically blasted the U.S. quality industry for not, for some of the lax things that they've done, and I think he was spot on. I've been looking for that speech. I know it was written somewhere, and I can't find it, but I should probably write his institute and ask for a copy. Anyway, when I moved to Connecticut, his institute, the Juran Institute, which was an educational and training and consulting society institute, was based in the town I lived in, Wilton, Connecticut. I went there several times. I never had a chance to meet him there, but I met everybody else that worked there, and I bought books, and it was kind of cool that I was in the same town as the Juran Institute. They've moved since out of Wilton. So, anyway, he was an engineer and quality consultant. He went to University of Minnesota, and then when he was in Chicago working at Hawthorne factory of Western Electric, he decided to go to Loyola Law School. Graduated, never practiced law though. He stayed true to his field of industrial engineering. He got the Second Order of Sacred Treasure in Japan and honorary doctorate degrees and various ASQ awards. And he's known for the Pareto Principle and the Juran Trilogy. So, for many phenomena, 80% of the consequences stem from 20% of the causes. That's the Pareto Principle. Goal setting has traditionally been based on past performance. This practice has tended to perpetuate the sins of the past. It's most important that top management be quality-minded. In absence of sincere manifestation of interest at the top, very little will happen below. Couldn't be any more true than that. The Pareto Principle, very important in quality. Also widely known as the 80-20 rule, follows the observations of this economist, Italian economist, Vilfredo Pareto, who showed that 80% of the land or wealth in Italy was owned by 20% of the population. He applied the same 80-20 kind of rule to quality issues. He coined the phrase, the vital few and the trivial many, to convey that small percentage of root causes can result in high percentages of problems. So let's work on those small percentage of root causes that cause most of our problems. It's very simple, but it was a big impact. Thus, prioritize your quality issues and work on the big impact defect types. Simple as that. The quality trilogy, we've talked about that a little bit here. Identify who the customers are. Determine the needs of those customers. Translate those needs into company language. Because the voice of the customer is in the voice of the customer. I want a smooth chocolate. We can't make smooth chocolate, but we can have a specification on viscosity. We can have a specification on density. We can have a specification on air content. We can have a specification on the granularity of the confectionery sugar we use and the kinds of chocolate we use and how long we mix them for and how well we grind them together. Develop a product that can respond to those needs. Optimize the product features so that you can meet the needs and the customer needs or surpass them even better. Then develop a process which is able to produce the product. We talked about that. And optimize that process. Furthermore, last, so it's quality planning, quality improvement, and then control it. If you don't control it, things will deteriorate. You have to have some little bit of quality improvement just to maintain the status quo. So prove that the process can produce the product under operating conditions with minimal inspection. Transfer the process to operations with a quality control plan for ongoing manufacturing of the product. And that's all it takes. So in the last subject here, process improvement and problem solving. The history, let's go back and talk about the history of quality a little bit. The history of quality follows the history and development of measurement systems. You cannot manage quality without measurements and regular feedback of those measures. So as we're able to measure things better, we were able to control quality better. So it's limited by your measurement device precision, accuracy, and reliability. The precision can it detect hundredths of inches or thousands of inches or 10,000ths of inches? Can it scale weigh grams and differentiate between grams or milligrams or even micrograms? And is it accurate? In other words, if you measure the same thing over and over and over again, do you get the same measure? So that would, and is it the right measure? If you get the same measure and it's wrong, it's not accurate. And reliability, usually when they talk about gauge and measuring reliability, is if I measure it, do I get the same answer as you measure it? Well, this was really important when most of the gauges used required a lot of human manipulation. Now a lot of gauges are kind of automated, so there's less likely to do that. History of quality is also parallels a history of weaponry and armaments, because that's one of the first applications and more popular applications. I don't care what you think about war and armaments and all of that. You could be a pacifist, but this is just a fact. If you look at some of the most high quality swords ever made, there were Japanese swords from centuries ago. And the way the metal was folded and heat treated and all these swords haven't lost their sharpness till today, and they sell for incredible. They bring incredible prices in auctions. Think about this. We went from muskets, which had no replaceable parts. So if my musket broke and your musket broke, I couldn't take the parts from your musket and the parts from my musket and fit a gun together. Let's say different parts broke. The hammer on yours might not even come close to striking the flint to create the spark to fire the actual musket. So there were no replaceable parts. Everything was built to order, and however they forged it, however they built it. Rifles, as soon as you could get to high-speed manufacturing, and one of the, and replaceable gun parts, that was a huge, huge leap due to the Industrial Revolution. So it's either armaments or alcohol. There's well-defined standard quality management processes for making beer in Germany. And it goes back, I think the first quality guild in the world was for beer making in Germany. And I think I've even read that in ancient Egypt, there was explicit standards for making beer and ensuring that the quality was the same. Same for winemaking. So the history of quality follows the history of measurement and the ability to make reproducible and identical parts. So it has to be a well-defined process, your manufacturing or your service, to deliver your manufactured product or your service. Just because a human being designs a process doesn't mean that it works as planned. So how do you study and fix a process that was created by human beings? Well, basically you go back to the 5th grade. What am I talking about? Well, problem solving and process improvement and problem solving. It's not this, it's this. Process improvement and problem solving. We use the scientific method applied to business operations and scenarios. The scientific method. But you're cringing. You're thinking, I remember that from the 5th grade. I never thought I'd hear about that again. Well, you are now. And Deming evoked what he called the Shewhart cycle. A lot of people call it the Deming cycle, but he always called it the Shewhart cycle. The scientific method. Remember that? Ask a question. State a hypothesis or develop a hypothesis. Conduct an experiment. Analyze the results. Is the hypothesis true? If it's true, you keep going, and now you have a model that you can use to predict states of nature. If the hypothesis was not true, go back here and restate the hypothesis, conduct another experiment, and try to see if you can find something predictable in that state of nature. So it's a proven method for learning about and predicting performance of natural phenomena. Well, we don't have mastery over a business or manufacturing process just because humans designed them or created them. So quality management brought this scientific method to business and manufacturing processes. And this is a 5-step method, and this is something I plucked off the internet at sciencefaircoach.com. Shewhart simplified it, plan, do, check, act. And he called this, spinning this cycle, this circle, basically was the idea of continuous improvement. If you have a problem or a quality item that needs fixing, what are your plans? What do you plan to do? How do you plan to do it? What do you think the root cause is? Execute, collect some data, check to see if the data confirms what you were talking about in the planning phase. And if that's true, then you take some action and change the way that you control the business process that you're talking about, and maybe make some design changes, and you keep going on and on and on. Plan, do, check, act. Plan, do, check, act. Later in life, Deming changed it to plan, do, study, act. But either way, it's the same. The scientific method applied to, again, I have problem improvement. It's process improvement, or real-time fix. Scientific method applied to the business and operations scenario, the Deming-Shewhart cycle, which we talked about. And guess what? You can't just use the scientific method. You can't just use the Deming cycle if you're a consultant. You've got to have your own special version of it. So people have 5, 6, 7, 8, 10 step, and even I've seen 12-step methods for this. There's something called 8D, which is 8-step method. 6 Sigma, which uses a 5-step method called DMAIC, which DMAIC, and you can look up what DMAIC is. Kaizen Blitz, any number of others. Why do we have so many of these? Because consultants can't just say, well, we're going to use this, or we're going to use a scientific method. I have my own proven 7-step method. I have my own proven 8-step method, and I have to differentiate myself somehow from my competing consultants. So there's a ton of these, but they're all equivalent. They all do the same thing. What do they all do? They all do this. And they can all be mapped to this. Even plan, do, check, act can be mapped to that. And I said we'd come back to Ishikawa. Ishikawa was a master of practical application. This book, The Guide to Quality Control, has probably been translated into, 20, 30 languages around the world. I first got a copy of it and read it in, 1979. And I don't even know where my copy is now. I wish I could find it. It's somewhere around here. But, I know it, so I don't really need the book anymore. And he basically said, as much as 95% of quality-related problems in the factory can be solved with the 7 fundamental tools. And the 7 fundamental tools were designed to organize and display verbal and numerical data. They were designed to be used by teams working, and it could be a team of factory workers. So it could be blue-collar workers, or it could be management level workers, supervisors and shift managers, and right up. And in fact, it didn't even stop there. You could take it to white-collar business processes and solve quality problems and improve business processes using the same methodology. His version of the scientific method was select the theme. In other words, define what it is you're trying to improve or the problem you're trying to solve. Collect some data. And basically, probably you're going to put a control chart on some of the key characteristics and collect that data over time. Analyze that data and look for what they call root causes. You see where they have Pareto chart? What are the different kind of defects that you're seeing from the data? Rank order them. Start working on the ones that have the biggest impact, that 80-20 rule. Find, and even before you do that, hypothesize the root causes for those defects. Pick the ones that you think are the most likely to have an impact on those 20% of the defects causing 80% of the problem. Plan a solution and implement it. Test it out. See if it works. Evaluate it. If it works, standardize the result into the standard operating procedures for that process. And then when he says reflect on the process, means what do we learn? What might we want to do next? Where else could we apply this same solution? If you evaluate it and it doesn't work, you go back to 4 and plan, and you plan the solution and do another test. You keep doing this using the best minds of people that know what's going on with that business process and that product until you find the solution and solve the problem. Normally, you don't have to cycle through very much. If you have the right people involved and focus on it, most of the time, especially in the low-hanging fruit kind of problems, it's because no one ever looked at it, no one ever thought to improve it. As soon as you start looking at it, you see glaring things that can be fixed. So this Guide to Quality Control is a very, very important book in quality management. It was a very important book. I don't know that people are still reading and using it very much. So that's my quality management introduction. Thanks for watching these 2 videos, and we'll talk to you again soon. Thank you.